Right, children. Now we are going to start the second chapter of this lesson. So, do you remember what we learned under the first chapter? We learned about the effects of magnets. Under that, we learned that magnets can attract some substances, but some other substances don't get attracted towards the magnets. And further, we learned different types of magnets according to their shapes, okay? And we did some experiments as well. Now, we are going to learn about magnetic poles. What is the meaning of magnetic poles, children? We are going to learn it under this lesson, under this chapter, okay? So the activity is, let's identify the poles of a magnet. Some of you must have studied about magnetic poles as well, but for most of you, this is a new topic, okay? So what are the things we need to do this activity, children? We need some file clips, we need a bar magnet, and we need a piece of cardboard. Let's write down. We need file clips, a bar magnet, and a cardboard. File clips, bar magnet, and a cardboard. Those are the things we need to do this activity. How to do this activity then? Let's see. This is the method. We label these diagrams. The magnet and file clips. So how to do this? Look at the method. Spread the file clips evenly on the piece of cardboard. You have to take the cardboard and you have to spread the file clips like this evenly. Right? Not only at one place, you have to spread the file clips evenly on the cardboard like this. Okay? And then slowly lower the magnet towards the piece of cardboard. We have to take the bar magnet and we have to slowly lower this bar magnet towards the cardboard, and you will see these file clips will get attracted towards the bar magnet. Okay? Now observe what happens and report the observations. You will realize that when these file clips get attracted towards the bar magnet, it happens in a certain way. We are going to do this activity now. So by doing this activity, we are going to identify the poles of a magnet. So I already explained you how to do this activity. We need a cardboard and we need some file clips and a magnet to do this activity. As the first step, what we have to do is to spread these file clips evenly on the cardboard. I have already done that step. You all can see. I have already spread these file clips on the cardboard. Right? So file clips are already evenly distributed evenly spread on the cardboard. What is the second step? I already explained, y'all. I have to place this magnet on the cardboard and observe what happens. Let's do that one now. Right. What can you all see, children? You all can see these file clips get attracted to the magnet. Observe carefully how they got attracted here, children. You all can see at the two ends, more file clips are attracted. Right? You can see more file clips than in the middle. So there are two sides. The two sides you can see there are more file clips than in the middle. So compared to the file clips that are attracted at the ends, you can see in the middle there are only a few file clips attracted. So what is the reason for this, children? That is because when we take a magnet like this, the magnetic power of the magnet, right? The magnetic power is spread throughout the magnet, but when we take the two edges, right, there's more magnetic power in the two ends. So there's more power or attractive power present at the ends of the magnet. Right, children? That is why the two ends can attract more file clips when we lower these magnets onto the file clips. right, than that of the middle, the two ends can attract more file clips. That is because there's more magnetic power, there's more attractive power at the two ends, two edges of the magnet. So you clearly observed what happened when we were doing the activity. So what did we do? Remember? First we spread the file clips evenly on the cardboard and then we slowly lowered the bar magnet towards the file clips. What happened, children? They got attracted towards the file clips. But did you realize that there was a specific way that they got attracted? This is the way. So more than to the middle part of the magnet, the file clips got attracted more towards the ends of the magnets, just like in this picture. Okay, children, we'll write that observation. More file clips get attracted two ends of the magnet than to the middle. More file clips get attracted to the two ends of the magnet than to the middle. To the two ends of the magnet than to the middle. We could see only a few file clips in the middle part of the magnet. To the either side of the magnet, when we took the bar magnet to the either side, to the two ends of the magnet, more file clips got attracted. What is the reason, children? Even during the experiment, I explained y'all that is because when we take a magnet, specifically let's say that when we take a bar magnet like this, right, the magnetic power is higher at the two ends. Right, even in the middle part, the magnetic power is there, but compared to the two ends, that is lower, right? Which means at the two ends of the magnet, the magnetic power or the attractive power is higher. That is why, because of that high attractive power at the two ends can attract more file clips to the magnet other than that of the middle part, okay? Let's write. The attractive power of a magnet is more at the ends than the middle. Right, more at the ends. The attractive power of a magnet is more at the ends than the middle. This is the reason when we take a bar magnet and when we lower it to that file clips, more file clips get attracted to the ends than to the middle. Okay, so remember, children, because of this reason, the two ends of the bar magnet, two ends of a magnet are known as the poles of a magnet. Okay, so under this part, I told you that we are going to learn about magnetic poles, right? So now what is the meaning of magnetic poles? Because of the higher attraction power of the two ends of the magnet, they are known as magnetic poles, okay? It's clear that the attractive power of the magnet is more at the ends than at the middle. The two ends where the power of attraction is more are called the magnetic poles. Okay, so if you take a magnet like this, what is the meaning of poles? The two ends are known as the magnetic poles. Magnetic poles. Magnetic poles. Okay, so if this is the bar magnet, the two ends with more attractive power are known as the magnetic poles. Now you know what is the meaning of magnetic pole is, right? So let's see the other activity. The behavior of a magnet. Now we all already know that there are the two ends of the magnet has more attractive power. Because of this reason, we name them as magnetic poles, right? So because there are two magnetic poles, we are going to check whether they are same or different, right? They behave in different ways because of this presence of magnetic poles. Activity. Let's identify the poles of a magnet. So by now we know that there are something called magnetic poles. So the two ends of the magnet are known as magnetic poles. We are going to identify what are these magnetic poles, whether they are similar or not, okay? So what are the things we need to do this activity? We need a wooden stand. And then we need a compass, right? And we need a piece of string and a bar magnet, okay? Let's write wooden stand. And we need a compass, a piece of string, and a bar magnet. And a bar magnet. So wooden stand, compass, a piece of string and a bar magnet. So how to do this activity? I will explain y'all. Look at this picture. Use the compass and mark the north and south on the table. You all know using the compass you can find the north direction and south direction, or any direction you can find using the compass. So first of all, you have to take the compass and find the north-south direction, and you have to mark the north-south direction on the lab table, okay? So you have to take the compass. Using the compass, you have to find what is the north and south. Let's say that if this is the north, this will be the south direction, right? So this one you have to mark on the lab table. First of all, you have to place the compass on the table. So the pointer will direct it towards the north-south directions. So on the lab table with a marker or piece of chalk, you have to mark this one north-south directions, and then you have to keep the compass away, right? Use the compass and mark the north and south on the table, right? Then hang the magnet steadily from the string to the stand. Now here we have to use a wooden stand. What is the reason, children? So for this experiment, we have to use a bar magnet, right? If we use an iron stand, like other experiments, most of the time we use iron stands. But here, if we use an iron stand, it will affect our experiment because you all know that iron attracts towards the magnets, right? So it will affect our experiment. Therefore, we have to use wood. So after doing the previous experiments, now we know that there's no effect of wood on magnets because magnets do not attract towards the wood, okay? Therefore, we have to use a wooden stand. Why do we have to keep the compass away, children? After marking the north-south directions on the table, we have to keep the compass away. That is because we are going to learn later, compass also has a piece of magnet inside. So if we keep the compass next to this one, again it will affect our experiment because we are going to use a magnet, right? Therefore, after marking the north-south direction on the table, we have to keep the compass away. And at the same time, instead of an iron stand, we are going to use a wooden stand as well, okay? So use the compass and mark the north and south on the table. And then hang the magnet steadily from the string to the stand as shown in the figure. Look at this one. Using the string, you have to hang this bar magnet, and after that, let the magnet be still. So after hanging this one, this will move a little here and there, right? So because the string is twisted, sometimes this magnet will rotate and it will move, and finally it will become still. After that, let the magnet be still, right? Now find the direction in which the magnet has stopped according to the marked directions on the table. So when the magnet is not moving or when the magnet is stopped moving, you have to check to which direction this magnet is facing towards. Most of the time in the bar magnets we used are marked in red and blue colors. Okay? So you have to check whether there's a specific way that these red and blue color face towards the directions we marked or not. Right? Do the activity several times and observe. How to do the activity several times? So after it becomes still, we have to observe the way it faces, the way it becomes still, whether it faces towards any direction or not. Then after doing that, taking that reading, then we have to move it a little bit again. So when it becomes still, we have to check whether it lies still in the same way as before. Okay, children? So, find the direction in which the magnet has stopped according to the marked directions on the table and do the activity several times and observe. We will do this activity now. Right, children? So, in the previous experiment, we learned that the attractive power of the magnet is more at the sides, the two sides, and these are known as the poles of a magnet. Now, this experiment, we are going to see what are these poles of the magnet, what are the two poles of a magnet, right? So, to do this activity, we need this wooden stand and we need a compass and we need a magnet, bar magnet we are going to use, and a piece of string as well. So, first of all, I am going to use this compass to mark the north and south directions. You all know using the compass like this, we can find out the directions, right? So, you all know this red side always points to the north direction, right? So, we'll see. I'm going to keep the compass like this so you all can see. This indicator shows where the north direction is and I'm going to mark it on the table. I'm going to mark this is the north. Right, children? Now I'm going to keep this compass aside. That is because this also has a magnet. Therefore, when we do this experiment with our magnet, the bar magnet, this magnet might affect. Therefore, I'm going to keep it aside. Right? Then what I have to do is I have to hang this bar magnet using this thread. So when I hang this one, initially it will move. It will move initially. And let's see what happens. So first it will move and finally it will stop. So we will see what happens then. Right. Now it stopped moving. Can you all see the red side of the magnet is facing towards the north direction and the blue side towards the south direction. So this side is north and the other side is south. Right? Now I will rotate this magnet again. I will change the directions like this and I'll check what happens. Right. You can see again this red side comes towards the north direction and the blue side goes towards the south direction. If we stop moving this one, I will give a little support to stop this one, otherwise it takes time. Right? You can see again this red side of the magnet lies facing the north direction and the blue side towards the south. I will again change the direction a little while sideways like this. You all can see again the red side comes towards the north direction and blue side goes towards the south direction. So when it stops moving, what happens, children? The red side always faces towards the north direction and the blue side always faces towards the south direction. No matter how many times I twist this and I try to change the direction, it again, when it stops moving, it again faces towards the same way. Red side towards the north direction and blue side towards the south direction. What is the reason, children? That is because, as I explained you all earlier, there are two poles in a magnet. These two poles are north and south poles, right? So if I take out this magnet, you all can see this red side is known as the north pole and blue side is known as the south pole. So when we hang a magnet, a bar magnet like this, when we hang a magnet freely, the north pole will always face towards the north direction and the south pole will always face towards the south direction. This is a special behavior of a magnet. Okay, children. So you observed what happened. So after doing the activity, I hope this is very clear now. What was the observation? Do you remember what we did? So first we have to hang the magnet like this, and when it becomes still, and first of all we mark the north-south directions on the table, and then we have to hang the magnet and let it be still, right? And then when it becomes still, we have to observe how it becomes still with us. There's a certain way or specific way. What happened, children? So you all observed that it always becomes still as the two poles, two ends face towards north and south directions. Do you remember what happens? The red side was always facing the north direction and the blue side was always facing the south directions. No matter how many times I rotated this one, moved this one, when finally it became still, always the red side faced towards the north direction and the blue side faced towards the south direction. Okay, so after doing this activity, it's very clear that when we hang a magnet freely or when a magnet is hung freely, it always becomes still along the north-south directions as the two poles face towards the north and south directions. Okay, children, let's write these things now. Observations. The magnet lies still between the north and south directions. North and south directions. We'll write within brackets. Red side towards north and blue side towards south direction. The magnet lies still between the north and south directions, which means the red side towards north and blue side towards south directions. Okay, so what is the conclusion? You saw that no matter how many times I moved it, it always lies still between like this. So it's very clear that when we hang a magnet, when it becomes still, the magnet always faces towards north-south directions. Okay, let's write that. Magnet that is hung freely always lies between north and south directions. A magnet that is hung freely always lies between north and south directions. Understand, children? Now we have to do a similar activity, the same type of activity to understand this better, right? Let's see. So I told you this is a similar activity, okay? Let's identify the poles of a magnet. Even the previous experiment, we need to identify the poles of a magnet, right? So what do we need to do this activity, children? We need a water basin. Water basin. And we need a piece of rigiform. Piece of rigiform. Rigiform. And a bar magnet. Water basin, piece of rigiform and a bar magnet. How to do this activity? Look at this one. So it's very easy to draw a diagram. So when we look at the diagram, we can understand this better. I have explained you even before when we write the method. If you can draw a diagram, it's better because we can understand by looking at the diagram as well. And we have to label the diagram too. So we will label this one first. This is the water basin, rigiform and the magnet. Water basin, piece of rigiform, and the magnet. Okay. So how to do this one? Let's go through the method. Do this activity on the same desk which was used for the previous activity. Do you remember what we did with the previous activity? We first took the compass and we marked the directions, north-south directions on the table. So we have to use the same place to do this activity as well, right? Which means we still have to use that table with the north-south directions. So I will, because I don't have space here, I will draw it here. So we mark north-south directions on the table like this before. Okay? So do this activity on the same desk which was used for the previous activity. Cut the piece of rigiform as shown in the figure. Look at this one. A piece of the middle part of the rigiform is removed as we can insert the magnet into this one. Right? So if we can use in double tapes, we can paste this magnet to the piece of rigiform as well. So why do we have to use this piece of rigiform? Because we need to make this magnet float on water. That's why we have to use the piece of rigiform in order to place this magnet on the rigiform. So even without cutting a shape like this, if we can paste the magnet to the piece of rigiform, that also would be fine. So cut the piece of rigiform. Then keep the bar magnet on the piece of rigiform and let it float on the water. Right? Identify the direction to where the magnet is heading after it goes still. So when it starts floating, when we place it on water, it will start floating and at one point it will become still. Then, as the previous experiment, you have to check to which directions these red and blue sides face to. Okay, when it becomes still, to which sides these red and blue sides face. Okay, repeat the activity and get observations. We can again move this setup a little bit and let it become still and check what happens. Okay, children, we will do this activity now. Right, children. As same as the previous experiment, by doing this experiment also, we can identify the poles of a magnet. So you already know after doing the previous experiment that when we hang a bar magnet, it always lies as the north pole of the magnet directed towards the north direction of the compass. Okay. So here to do this experiment, I explained you all how to do this one. You all can see I have fixed this magnet. This is also a type of bar magnet. I have fixed this bar magnet to this piece of rigiform. So what I have to do is I have to place this apparatus on the water, right? So here you all can see earlier I marked the north direction. For this experiment also I am going to use this one. So I am going to place this piece of rigiform like this. Check what happens, children. You all can see clearly what happens, children. Now this is the north direction. You all can see the red side of the magnet is the north pole, blue side is the south pole. You all can see the north pole directs towards the north direction and the south pole directs towards the south direction. I will rotate it a little bit like this. Right. See what happens, children. Now you all can see it again rotates as the north pole directs towards the north direction and the south pole directs towards the south direction. So it's very clear the magnet has a special behavior of facing the north pole towards the north direction and the south pole towards the south direction. Right, children? So you observed what happens, right? So we used a piece of rigiform with a magnet like this, and when it was floating and when it becomes still, you saw what happened. The red side of the magnet always faces towards the north direction that we marked, and the blue side always faces towards the south direction that we marked on the table, right? No matter how many times I turn this setup, it again stays still between the north and south directions. Okay, children? Let's write that. When the magnet with the rigiform becomes still, the red side always faces towards north direction and the blue side towards the south. When the magnet with the rigiform becomes still, the red side always faces towards north direction and the blue side towards the south. Okay, children? So what is the conclusion? Just as the previous experiment, it's very clear when the magnet becomes still, a floating magnet becomes still, what happens? Always the two sides lies between the north and south directions. Okay? Let's write. A magnet which is floating stays still between the north and south directions. A magnet which is floating stays still between the north and south directions. This is the specific behavior of magnets. Okay, a magnet that is hung freely or magnet that is floating, any type of magnet, when it becomes still, what happens, children? It always faces towards the north-south directions, right? If the magnet is a colored one, like in blue and red color, if it is colored, we can observe this very clearly, very easily we can observe. The red side will always face towards the north direction and the blue side will always face towards the south direction. What is the reason, children? Because these two sides are the magnetic poles and these poles behave in different ways. That is why. Let's say it's clear that the magnet always stays still between north and south directions. We can identify that the north pole of the magnet is the north of the compass and the south pole of the magnet is the south of the compass. What is this north pole and south pole of the magnet? Now we already know that magnet has two poles, two sides or two ends. So if you observe the magnet carefully, you will see the red side, there's a mark as capital N. In the blue side, there's a mark as capital S. Right? The red side is marked as capital N. The blue side is marked as capital S. So you know that when we hang a magnet freely, what will happen? It always stays still between the red side to the north direction that we marked on the table and the blue side towards the south direction. So the red side, as it faces towards the north direction, we call this side north pole. As the blue side faces towards the south direction always, we call this pole as the south pole of a magnet. Which means the pole, the end of the magnet that always faces towards the north direction is known as the north pole, and the pole of the magnet or the end of the magnet that always faces towards the south direction is known as the south pole of the magnet. Okay? So we mark the north pole of a magnet as capital N and the south pole as capital S. So this is the south pole, this is the north pole. We'll write south pole. In most of the magnets it is blue color, right? North pole. North pole. Most of the time it is red in color, colored in red. So by now we know that a magnet has two ends with more magnetic power, and these two ends are known as poles of the magnet, and now two poles are there, north pole and south pole of the magnet. I hope up to this part is very clear now. So here look at this one, this is for your extra knowledge. The pilots, sailors, explorers and soldiers use the compass to find their direction. Because using a compass we can easily find what are the directions, north, east, south and west directions, okay? So do you know that when we use this compass, this pointer, this needle of the compass is also, it is a tiny magnet. Okay children, it's a tiny magnet that is pivoted or balanced on a tiny pointer. Because from the middle, let's say that if this is the needle of the magnet, and one side is marked in red, that is the north direction. So this one, this tiny magnet is pivoted or balanced on a tiny pointer. Because from the middle it's balanced on a tiny pointer, this tiny magnet can rotate or it's movable. Okay children, that is why whenever, even though we move the compass here and there, each time this pointer faces towards the north direction. The red side faces towards the north direction. This is a tiny magnet. Okay children, so it's very important, this type of compasses are very important for pilots, sailors, explorers. So when we engage in jungle exploration, we have to take a compass. When we are lost, it can show us the direction. Okay children, so we have completed the second chapter of this lesson. We are going to start the third chapter now.